Ivan spent the first 5 years of his career in web development. When he creates websites in Macromedia, Flash, PHP, Ruby on Rails, and jQuery. Later on, Ivan worked on an insurance aggregator platform in Copenhagen. In Copenhagen. Well, Ivan's brief experience with Java took him to Ocado Technology in the United Kingdom, where he worked on cutting-edge software for the second generation automated warehouse, a highly available distributed system based on Akka and Scala. During his time in Ocado, Ivan had a taste of running and supporting a complex system in production by joining the DevOps support rota for the whole warehouse and dealing with a couple of large-scale incidents. 5 years ago, Ivan joined QuantumBlack, a data science consultancy owned by McKinsey, where he applied all his previous experience in software engineering to bring a better engineering practice to the data world. Ivan, it's great to have you on the MLOps community meetup. I'm excited to learn about Kedro and all that comes along with it. Welcome to the meetup, Senor Ivan. I'm going to stop sharing this so you can hear me without reverb. So I think we've got everybody here. We've got Ivan with us. I'm ready to start this. Let's start the show, man. Let's get this going.
Yeah, let's do it. That was an experience. It's probably the first and the last song about me that I'm here. So.
Don't worry, you can come on again if you want. I'll make you another song if you want to feel special ever again.
I'll prepare my bio in rhymes next time, so it will be easier.
There you go. There you go. I'm still waiting for the first guest who's going to actually do that one.
Maybe next time.
Awesome, man. Well, I'll share my screen because we've got something super cool with Ivan happening today. This is like we one-upped our game today when it comes to the technology aspect. If anyone wants to follow along on the slides and you don't want to just watch this screen, you can do so at the link provided in the chat. Also, of course, we encourage questions. Feel free to throw them at us. And at the opportune moment, I'll stop Ivan and ask the questions if need be. For now, I'm going to share my screen and let you get started, Ivan. It's great to have you here, man.
Yeah, it's great to be here. I'm really excited. Let's see. Okay, I can see the slides are shared. Okay, welcome everyone on this call. I'm really pumped to be here, and also it's super exciting to start a presentation with a song. So let's move on into a little bit of a more traditional style of presentation, where I'll talk a little bit about building 12-factor data apps with Kedro. First, a little bit about myself, even though Demetrius did a great job introducing me. Currently, I'm tech lead and / engineering manager for Kedro. I'm a bit unclear about my role, but that's why I introduced myself this way. I've been working for Kedro for the last 4 years, and it's a product developed by QuantumBlack, where I'm a machine learning engineer. And I've been with QuantumBlack for the last 5 years of my career. I have about 15 years of experience building software. And I'm trying to bridge the gap between software engineering and machine learning and data science, and trying to bring along my experience with it, successfully or not so successfully, depending on different circumstances. I'm a Bulgarian living in the UK, and Technical University of Sofia and Technical University of Denmark alumni. So the agenda for today is to start discussing a little bit my motivations for this presentation and why I thought it's a good thing to discuss 12-factor methodology with conjunction with Kedro, and then describe the 12-factor methodology to the people who are unfamiliar with it. Then maybe introduce some of the basic aspects about Kedro and how it can help you build machine learning pipelines, and then try to reframe data pipelines and machine learning pipelines as data apps, and have some conversation opener for why they are similar to web apps in one way or another. And as my first 5 years of my career were with web apps, and I could see a lot of similarities. And then I hope that I get some questions and maybe even have those ideas challenged and spark a discussion at the end of the session. I'm really excited to hear your opinion on these ideas. So when we start out, we always need to ask the question, what are you trying to build? And the reason for that is different things have different requirements. And for example, if you're just trying to draw insights from data, you need to consider some things, and then you can leave many other things aside. But if you are trying to do something more than that, you might need to reconsider the way you're building stuff. When I joined QuantumBlack, like a lot of our clients, they were at this stage when they were just drawing some insights from data, and they would never want to repeat the same thing again. They would just have this project for a few months. When they try to find out like what is happening, they used to apply some machine learning, but essentially most of the work was a little bit of glorified business intelligence. But over the last 5 years, we've seen our clients evolve, and they want to start having something called machine learning products, which is essentially bring the same process but large scale and in a way that is repeatable. So you don't want the insights or the recommendations done only once, but you would like to have them done multiple times on demand, or maybe having a dashboard which is always up to date and live. And this will help the C-level and different levels in the company to make decisions. And we, in QuantumBlack, as a part of McKinsey, we often interacted with like enterprises that are there for like very big businesses, and they needed to make like very high stake decisions. That means that they needed to have a very reliable machine learning product. So the moving from a shed in the field, which is very comfortable for a person, to like, I don't know, 20-story flat or building with flats is one of a like very different mindset. So building machine learning products is what we are going to talk about now. How do we scale from this one shed in the field? And since history doesn't repeat itself, but it often rhymes, I wanted to look at previous experience and how we did that in the software industry. Was there a moment where we needed to achieve massive scale very rapidly? And indeed, there was. And if you look at the internet users by world region since 1990 graph here, you can see that up until the 2000, the internet was mainly a Western European or North American phenomena. Like there weren't that many global users. And at that time, like I tell it as a joke, but it might have been technically true. You could turn off the website in the evening or turn off your server and then turn it on in the morning, and that wouldn't impact much of your business. But from 2000 onwards, most companies, they wanted to go global, and they made huge bets on capturing all that growth that is happening, which was essentially an exponential growth in users. And not only the users became more, but they started interacting with the web much more frequently. And that increased, like it had huge demands on the services, and people needed to find ways to scale rapidly. So I think the most interesting period is the period from 2000 to 2010. And in the notice, and if you look historically, a lot of web frameworks were developed back then because they had to find a way to scale this. So everyone wanted to be on the internet. Everyone needed to have a website. And you couldn't do that by having a Snowflake project every single time. And moreover, that's the time for really huge companies to get into that space. Like at that time, the most dominant social media was MySpace. And Google was just overtaking like Yahoo as a search engine, and there was Alta Vista also, and it was very, time of very rapid evolution and development. And they couldn't have done this without knowing how to scale their applications. So how did they do that, and how did we achieve scale in web apps? And this is a list of mainly my take on that. So these 5 things were really, really important for scalability or scaling in web apps. One of the most important things was portability, because at that time it was fairly common if you work in the web industry, like when you work in not in a very good way, that you run something on your machine and then you give it to your fellow developer and they can't run it on their machine. And that problem was rampant everywhere. Like it happened also when you need to deploy things on one server, it would work, on another server, it won't work, and so on. That might sound familiar now if you're in the ML space. And the reason is because we're kind of repeating that pattern less often now, granted, than it was a few years ago, but it still happens. Another important thing is this interoperability concept that meant that like a lot of these applications, they needed to interact with each other. That led to the development of different interfaces, different ways for those applications to interact, and eventually led to the birth of microservices, which was impacting the idea of modularity, that you don't need to have a single monolith application, that you need to develop it first and then launch it, but you can develop it piece by piece by independent components, and then eventually evolve your application. There was a rapid standardization. There were tools that were being standardized. And I think the most important thing was actually the culture, because once you start applying standards or best practices, you don't always apply them in the best way possible. You always have your own take on what the standard says or what the best practices are. And to me, that's culture. And that's when the DevOps culture developed, and people started talking about DevOps. I think this is fairly important for MLOps now, because MLOps is in a way branching off DevOps, and we want to see similar patterns or similar culture being developed within the space of machine learning and data apps. And I think one very important aspect of that culture is the 12 factors. The 12 factors was something that people at Heroku came up with, and they presented it at the end of that decade that I'm talking about. And they were observing that through their clients. And Heroku is platform as a service, where you could just, if you were deploying an app, you could use them, and it was just like one-click deploy, and people were super happy to use it at that time. And they observed different applications, and they made a distinction between apps that were easy to scale and apps that were not easy to scale. And they came up with these 12 factors that would kind of easily determine if an app was easy to scale or not. So I will go briefly through each of those factors and describe what they are about. And then I'll leave it to you to decide if that's important for machine learning and the data space. So the first one is Codebase. That's how they named it. But the idea is that Codebase is a single repository in a version control system, which means that if you had an app, it needed to have a code base that will correspond one-to-one with it. So you shouldn't have like more than your app shouldn't span across multiple code bases, because this is essentially a distributed system. Or if you have in one code base multiple apps, it's in a way a distributed system for code. It's at the build time. And the best way to deal with these kind of things was by factoring out libraries, and then your application would use, and you don't need to share code in applications. I know like some people might say, okay, this is the monorepo versus multi-repo discussion, but I think it's a little bit more than that. So it doesn't preclude of you having monorepos. It's just the idea that you need to have one code base for your app. Having that, like defining what an app is and what a code base is, you can also have something called deploys, which means that using one code base, you would have multiple deploys. So your application could be deployed multiple times without a single change in your code. And the only difference that is allowed is obviously different versions. So you can have one app being a version 1, version 2, version 3, and all of them in production. But there shouldn't be different code or application in different code bases. I can see this one violated quite often. I must admit that less so now in machine learning projects, because often there's like a small tweak here and a small tweak there that people like to do, instead of making something that is configurable and then you can just deploy it in different places. Dependencies is the second one. When people develop applications, they usually have an environment they work on, and this is, it doesn't work on it works on my machine, it doesn't work on your machine problem. It mainly stems from this. The idea is not to rely on system-wide packages. So you cannot assume that the environment will have the same packages as yours. And it means that you should declare all your dependencies in a special file, and then eventually install those dependencies in the new environment. And at the same time, it's quite important to have a dependency isolation during execution. This is taken nowadays to the extreme with you have Docker, which achieves in a way that every single time you build an image and you run your application, it's in a way, it isolates all of your code into a separate thing. That means that you can ensure portability and onboard new people very easily, deploy to different environments and so on. And you can see the culture that these 12 factors kind of like try to establish as best practices. It continues to live on even to these days now. Another one is configuration. And here it's really important the way they define configuration. And in a sense, configuration is not everything that you can configure, but it is everything that can change between different deploys. That means like access to different resources, a database system, of S3 system in our context, and anything like that. Also credentials for accessing different systems and so on. What is not configuration is internal application settings. I deliberately used a different word here, but you can also call it config, but it's not really a config in the context of 12-factor app. Because you wiring up modules of your system should be done in code. That's the best way to do it. And you don't need to have a YAML file here and there that needs to change at runtime, because if you change any of those things at runtime, you're not guaranteed that your application will work. So the only thing that needs to change at runtime is config in the context of something that changes between deploys. This strict separation of config from code is quite important, because then you might, like when you're dealing with operations of a system, you can somehow sandbox it and say, okay, I don't need to know any of the inner workings of this application. I just need to know how to configure it. And as you can imagine, this helps tremendously in DevOps. So I touched briefly on configuration. What do you configure in configuration? And that's actually the backing services. And that's any service consumed at runtime. And there should be no distinction between local or a third-party service. So if your application works with S3, it should be able to work with local file system as well. And that's for our example here. And that should only be changed through configuration. And yeah, this way, each distinct backing service is treated as a resource. And the good thing about resources, they are considered swappable. So you can just swap things depending on what you need in different environments. There is also the split between different stages. So you have strict build, release, and run stages. So this separation is quite important. And together with the previous one, and talking about configuration and backing services, this is often violated in the data science world, or at least in my experience. And one of the main reasons is that people are used to work with interpreted languages, and there is no explicit build phase in interpreted languages. Essentially, you treat them like scripts. You can run it, and no build like in, for example, Java or Scala or C. So people all forget that there is a build stage, which can convert your code into an executable. So the release stage is actually taking that executable and combining it with your configuration to be able to deploy things somewhere. And then run stage is when your application starts running. It will pick up the configuration in your environment, and then it will run in your environment. That separation is super important, because having this, it kind of makes it super easy for you to know when something should happen and when something should stay untouched in that stage. And debugging is quite, I would say, eased a bit with this one. So there's also one for processes. The idea is that you should run your application as one or more stateless processes that share nothing between each other. And if there is any data that must be stored or shared in a way, it needs to be done in a stateful backing service. And that's typically a database in web apps. In the data context or machine learning context, you have S3 backing services, or you might have some data lake or a custom data lake that you have in your organization and so on. I think that's something that the data world is fairly familiar with, because it comes with another factor that I'll talk about later. And you cannot rely that your memory or cache will be available for future runs. You know that like anything that needs to be available for future runs need to be stored in a stateful backing service. Another factor is called port binding, even though I think that's a poor naming on their side when they announce this, because it's actually about self-contained applications. At that time, especially in the Java world, there was the concept of application servers. So you install your application by uploading a jar file, which is, for those of you who don't know JVM, the JVM ecosystem is kind of like a library that you can add during runtime of another application. So your application would be a jar file that you need to inject into this application server. And that was like a very common way of doing stuff. Even if you think about PHP, they would have an Apache server that would load in something, and then you would deploy your application somewhere on that Apache server. And then you would need to, if you could theoretically deploy many applications in the same Apache server. The 12 factors, they stated like, you shouldn't do this way. Actually, your application should be fully self-contained. It means that it will run its own servers inside and export that service to a port. And you should serve all your requests on that port. And that's quite good, because actually doing it this way, it helps with interoperability, because once you bind your application to a port and you have an API exposed on that port, then your application can become a backend service to another app. And that's very conducive to scaling out your application. So one service can be both a backing service and maybe even directly consumed by the user. Concurrency was the 8th factor that they were talking about. And having established that processes are first-class citizens, then the way you need to do things in a concurrent way is that you just have some work type that is assigned to a process type. And this model makes scaling out very, very easy, because when you have share nothing horizontally partitionable architecture, that means that adding more concurrency is very simple and very reliable. You just run the application one more time and then on a different machine, and then it will work. And then you have a load balancer that will send things and send requests to different instances. That also means that, like, when you're working with the process managers, like, you shouldn't have your own custom ways of starting and stopping the process. You just need to rely on the operating system's process manager. So all shutdowns should happen in the same way that you would run and start any other application. So as I mentioned, like, disposability was quite related to these processes and the previous factor. And the idea is that these processes, they are disposable. So what does it mean to be disposable? So it means that, like, if you start or stop them at any moment, your application will not leave things broken or corrupt. That means that your jobs should be reentrant, and you should use transactions or idempotent operations, and processes should shut down gracefully. That makes it very robust against sudden death or failure. Now, to argue that this factor is probably one of the most familiar to machine learning or data scientists and data engineers, because we are used to very long running jobs. And we know that once you run something during nighttime, it's very likely that it might fail. And you don't want to have your work start from the beginning, or, like, the worst thing is to change some of your data that you will no longer be able to actually use that data again. So this is one of the things that just maps and very naturally to the way we work, and we worked from the very beginning of even when it was just pure data analysis, something that now transformed into data science. Dev and production parity is another factor they have, and the idea is to keep the gap between dev and production small. And there are 3 different gaps that the 12 factors identify. The time gap, which means, like, deploying code to production should be done in minutes or hours, not days or weeks, because the longer you wait, the bigger the breaking change could be. The personnel gap, which means that developers should be closely involved in deploying their code. And the tools gap, which is, and the way to close that one is having development and production environment as similar as possible. So working in a consultancy, I've seen this being violated quite a few times. Like, for example, the time gap, it's still common for like when you work with clients, they don't do deploys daily. Deploys still happen, and you have a time window. With some clients, we had only a certain time of the day. You would have a deployment window of like 1 minute. If you don't have your artifact there, you cannot deploy until the next day, and then something will break, and then you need to wait for a week for this one to be fixed. And obviously, this is not very good for continuous deployment, which is something that helps preventing some really, really bad bugs, and it's very hard to fix. The personnel gap is something that consultancy face all the time, because you develop something that's, by the definition of a consultancy, is that someone else will operate it after that. You just leave your code there, and then there needs to be ops people. Nevertheless, I think we're trying to close that by making sure that our people can go there and deploy their code and teach or show how people can operate the applications. And the tools gaps, I think that one is closing. At least in my experience, I've seen people are trying to mimic and copy environments, but nevertheless, sometimes the environments are not the same, or we don't know how to make the code independent from the environment, and that can cause to some issues here. One important thing is that when we're using backing services, it's good to use similar or exactly the same in different environments as much as possible. Obviously, that's not always possible. If you're developing locally, there is no way for you to have, I don't know, it's quite hard for you to have S3, so people usually run some kind of copy locally and things like that. I'm just picking this as an example, might not be the best example, but you get my point. And then logs, very related to the introduction of one of the 3 t-shirt designs. If you're, how is it? If you're uncertain about something, better log it out. So the idea here is that logs should be treated as event streams. What does that mean? That means that you shouldn't be concerned with logs at all in your application except producing those logs. So no routing, no storage or processing of those logs. That's none of your application's business. And you should just write those logs to std out and buffered, and that's it. You leave the capturing, collecting, and archiving of logs to external systems in the environment. And this is one of the things in DevOps world is people have some clusters or even services or even SaaS solutions that do that for you in the best way possible, something that you can never do in the same way. And I still see some places and some people keep parsing their own logs to understand if something failed the last time that it was running, so they can do some decisions based on that. And this is definitely not something you should do. Because logs are unreliable. They can be redirected to any different places, and you cannot rely on something being there. Even worse, if you log things to a machine, you don't know if that machine will have enough disk space for your logs to be there. I've witnessed that personally on several occasions in my previous work life. And the last one is admin processes, which means that if you have some one-off tasks, they shouldn't be part of your application, but instead you should have them part of the same code base, and you should be able to run them in the same environment as the application. And one example here is, for example, creating the database schema for your application in the web app world, but also that could be copying data from one place to another in the data world. Let's say you have a landing stage or landing place for your data, and you want to do something with that data. This should either be done as part of the pipeline, or maybe if you have a one-off process that does something, or maybe initiates or some directory structure or anything like that, it's better not to be part of this application. Nevertheless, good to have the code as close as possible to the application, so in the same code base. And that's about it. Like that's what the 12 apps were. One would ask, like someone might ask now, how to build a 12-factor app? Do I have a checklist that I carry around and then see if I'm checking against any of those? And the reality is that no one does that, and you never know, like, okay, how you can violate some of those factors. And to be frank, like, it doesn't matter if you violate one or two of those, because this is not a standard, as I mentioned. At least I don't believe it is a standard, but it's rather part of the culture. And how can you enforce something like that is constantly changing? And one of the things that people did was they just embedded them in the frameworks they used, like in the web frameworks. Things like Rails, Symfony, Spring Boot for Java, Django for Python, and Play for Scala. And having all of that, it meant that if you use any of those frameworks, you automatically get, I don't know, 10 out of 12 of the factors for free, and then you just need to think about the other two, only if they're relevant for your use case. And you just package your thing in Docker, and then run it on Kubernetes, and that's it. So this adhering consciously or not so consciously to those 12-factor apps meant that for you, it's very easy to package your code in a Docker image and then run it on Kubernetes. So Docker was, in a way, like the final pin that made factor apps the thing people would use to make microservices. So talking about frameworks, I think it's about time to dive into Kedro, which is a framework. It's a Python framework. And the reason why it's a Python framework is because Python is the lingua franca of data science and data engineering these days. And we aim to be a one-stop shop for structuring your machine learning projects. And also a tool for your teams to create machine learning projects very quickly and rapid development. So it is very easy to deploy afterwards. Yeah, I just read the chat. When in doubt, log it out. I like it. So completely agree with that. So where does Kedro fit in the whole process? And if you can cut the whole building machine learning pipeline process into different stages, and I would roughly split them into these stages, but you can pick any other, I don't know, a taxonomy. Let's say you have ingesting raw data, then cleaning and joining that data, then you engineer some features, then train, test the model, and then you deploy the model, and that's it. And Kedro aims to be with you along the whole journey here, including the deploying to model, the deploying to some environment, deploying your models, but not so much in the operation side of your models. So we would leave that to the orchestrators. And that was like the thing that Kedro was most often confused with in the beginning when we launched it was it another orchestrator? Was it something like Airflow? And the answer to that was always no. Actually, we are concerned with the authoring of a pipeline, where Airflow and Kubeflow and others, they are orchestrators, and they're concerned with running your application or running your workflow or running your machine learning pipeline, and making sure that that pipeline will run at certain time, and you will know when it fails, and you will know how often it runs or how often it runs successfully, and so on. This is not the focus of Kedro. The focus of Kedro is for you to produce something that is worth being run often. So maybe a different way to compare Kedro with existing tools here is this chart here. On that landscape, you can see different tools across the dimensions that we think are relevant. And Kedro helps you alongside many of those dimensions, except the scheduler and monitoring. There are tools that help you with that, like mainly the orchestrators. They're mainly concerned with that. They have a visual way, like a way for you to create a workflow, because there's no way for them to work otherwise. And they have a way for you to visualize that workflow. But I think their main selling point is their schedulers and monitoring and being able to orchestrate their runs. One important distinction of Kedro with orchestrators is that typically the orchestrators are task-centric, because they do not concern themselves with whether you will have on that step you will load data or not, and how to load that data. They leave that to you. So you need to manually write that step and add it to your script, and then you load the data from there. You need to take care of that. Obviously, they start to add some ways for you to do it in an easier way, but they're not data-centric. Where Kedro, alongside, for example, DBT and Pachyderm, they're data-centric DAG builders. And the difference here is that you have some workflow that you only specify the processing that needs to happen at certain steps, but you are not concerned with how you load the data. And how you load the data is something that you need to specify through configuration. So who is using Kedro? We have a growing community at the moment, and we have more than 4,500 stars, more than 100 contributors. There is a bunch of companies that have publicly stated in one way or another that they use Kedro. There are many more that they haven't reviewed, but unfortunately we can't add the logo here. And this list is growing by the day, and also the number of users that we have are growing by the day. So now enough with the sales pitch, and moving on to the Kedro concepts and what they can what you need to do, like what you need to understand in order to grasp a Kedro application. And there are four main things. One of them is the project template. The other one is the nodes and pipelines concept, which probably most of you are familiar. That's fairly standard for machine learning. And then you have the configuration system, which underpins the catalog. So this is what the project template looks like. This is the default one. It will be generated when you use Kedro New. So it has a CLI as well, Kedro, that will help you with things. And at first it might look like, whoa, there's so many things here, but I have nice highlighting here that I can describe each part separately. So you have a configuration folder, which has the base configuration, which is just the catalog, logging, and parameters. And that base configuration is something you share across different environments. And then you have per environment configuration. That's not checked out usually. Obviously, that's where you need to place your credentials, that they shouldn't be checked in your repository. And yeah, that's how you define different configuration for different environments. You have the standard PyProject TOML, which is pretty standard these days for any Python project or modern Python projects, which configures anything necessarily for, Python packaging. And talking about Python packaging, there is the source folder where you have the standard Python package structure. So pre-generated, it will have the main the main package or module, Python module, which will have some of the files in there. And then you have tests. These are just stubs, like the very simple ones that if you want to write tests for your code. And then you have a requirements file where you can add all of the requirements. Nothing too exciting here. You have settings.py. As I already mentioned, this is where the application config sits, and this is a thing that doesn't change between different deploys. But this helps you with wiring up your application. For example, some things that you can configure is, okay, should I load my configuration from the conf folder, or I can just point to a service that will have my configuration, and so on. And then you have the pipeline registry, which is where you place your pipeline and you define your pipeline and the pipelines that will be exposed to your orchestrator, your user. So the other concepts are the node pipelines, and that shouldn't be too unfamiliar to people who have done data science or a data engineering project, but I will step through it. So you just get the pipeline and the node. You create a pipeline in a function, and the pipeline is just an object, which is a list of nodes. And what is a node? The good thing in Kedro is that a node is just a normal Python function that has inputs and outputs. And you provide that function. So the node is a wrapper of that function. And instead of providing the data, you just provide an alias for those inputs. So the alias here is companies. And then you have an alias for the outputs. And if you have multiple, then you can just list all of them. And then you can name that node. And that's all there is. And this is an example function. And as you can see, it's just a normal pure function. So if you know functional programming, a pure function is something that just has input and output. That's the only way it interacts with the outside world. It doesn't try to write or load anything from within. Obviously, there is no way for us to enforce that in Python, but this is just the recommendation we have. If you want to have your pipeline being done correctly, you just need to rely on your arguments of your function and then return the result. And this is the pipeline registry, where you have a function which is called register pipelines. That's what we look for. And then what you do have at the end is just return a dictionary with the names of your pipelines and then the pipelines themselves. And we have some handy stuff, like, for example, you can plus 2 pipelines, or you can sum a bunch of pipelines or anything like that. So there is some algebra to the pipeline objects. So if you do that, then you get for free very nice and beautiful visualization of your code. So this will show exactly as you have described your pipeline in the pipeline registry. It will show it in Kedro Viz. And Kedro Viz is a plugin that we have for Kedro, which honestly has been like really, really loved by the community, and people are super happy that it finally gives them a way to communicate with non-technical stakeholders about the work they're doing. So now you can say, okay, I'm working on that particular part of my pipeline. This is where we have problems. This is where like that part of the data is, which is not really good, and so on. And browsing around and introducing new people to your project, especially when these projects grow big, this is the go-to place for that. And the good thing about this one is that it doesn't need any, you don't need to draw this or produce that documentation. It's automatically derived from your code base and from your pipeline registry. So moving on to the configuration system, and maybe I see that there's some questions here, but maybe after this we can pause for a while and Demetrius can ask some questions. So the configuration system has 3 main components, and the first one is the build configuration, which you use during development. during developing of your application, and that's the develop time configuration in PyProject TOML. It's pretty standard. It is what most Python packages use and Python projects use, and we didn't add much to it. So the second type of configuration you have is app config, which is used when you package your application, and that's settings.py, and I would even add pipeline registry. So this is how you wire up your application, how you add things to the behavior of your application, and this doesn't change between different deploys. So the thing that changes between different deploys is the data config, and that's the configuration that's in the folder conf/. And this is configuration that is being loaded at runtime. And that configuration is essentially telling your application where to load and where to save the data to. So this is how the build config looks like. As you can see, these are like standard things like iSort has a section there if you want to add things. You have PyTest, it has a section there, but we also have a section there for Kedro. So this is what the app config looks like. So this is settings.py, and then you have a bunch of constants that you can modify or add things. And this way you configure your application and how you should wire up things. And the catalog, this is one of also the most beloved features is, okay, so it's just a YAML description of where to load and where to save the data from and to. So you have all of those aliases that I was talking about earlier when you were defining your pipeline. And then you just declare that this is a pandas CSV dataset, which is being loaded from that particular CSV file. And that's all there is. So if you want to add some special things, because the hood, it uses read CSV, so you can provide all of the parameters here, and that's it. But the good thing is that, let's say you move to a different environment that you don't want to load it from that place, or you just want to load it from S3, then you simply change the configuration to point to the different place and the different data format, and then your application is good to go. That's it. You don't need to change a single line in your code base. It's just configuration. Different types, like for example, you can have an Excel data set. We have a bunch of different types that are pre-built in Kedro. And if you want to build your own, that is super easy. And maybe now it's a good time to see if there were some questions on the previous sections.
Yeah, so you use the web app development as an analogy for MLOps at the beginning of the talk. What would Kedro be in the web app development world?
Yeah, so Kedro would be like in the data app world. That's what Kedro is the framework for building those things. But in the web app development world, that would be one of the frameworks that I introduced earlier, like Django, for example, or Ruby on Rails, or any of those.
Excellent. Cool. I think that was all we had. I love this Kedro Viz thing, though. That's pretty amazing. Yeah,
that's everyone, like when they see Kedro Viz, that's the thing. They don't listen for the code part. They only look at Kedro Viz. But people love once they learn more about the other things. They love Kedro. And now I think actually this question was very good, because it is, with this section, I'm going to draw the parallels even further between web app development and machine learning pipelines, because I want to reframe them as ML pipelines are, let's call them data apps. And that's my framing here. So looking at the two worlds, the web app development and the machine learning pipelines, all of them are roughly based on two different design patterns or architectural patterns. And for those of you who are not familiar, like MVC is the web app design pattern, and ETL is the ML pipelines design pattern. So MVC comes from a model view controller, and all frameworks that are listed there, they are based on one or another flavor of this design pattern. For example, Django would not claim that they're MVC. They have different acronym and they have different things. But at the end of the day, it's just MVC repackaged in different ways, maybe with some tweaks, and some things are a little bit different. But the main idea is this. So you have a user which sees a web page. And then on that web page, by the way, MVC is being used also on GUI development on desktop. So it doesn't need to be a web page. It can even be like a screen or on an application, and then you have a button. And when the user presses that button or clicks on that link, in your application, that action is being processed by a controller. And that controller does some changes to a model, which is where the data sits. And after it makes those changes, then it kind of like continues by forcing an update to the view, which means that the user will see a different view or different page at the end. And this continues, like with every click, this cycle happens all the time. On the other hand, like when you look at the ETL pattern, we have on the surface quite different interaction, right? You just have an extract phase where you get the data from all of your sources. And then once you do the extract, then you do the transformation of it, maybe cleaning it, maybe joining it, maybe applying a pipeline, a machine learning pipeline on it. And then you load it into a data warehouse or a data lake or somewhere where the data is ready to be used or maybe ready to be visualized. And you might have many steps like this, or you might have a full pipeline that is being created, but overall, this is all there is. This is like the main architectural pattern. And there are different flavors again for this one. People say, okay, we're not doing ETL, we're doing ELT and so and so, but the main idea is the same. Again, I will continue even further with overgeneralizing, and I might surprise you, but I will tell you that if you squint your eyes hard enough, these two patterns are very, very similar. And yeah, people might disagree. Maybe I squint my eyes too hard, where everything looks the same, but to me, they are not too different. And with the next few slides, I'm trying to show why. So, for example, this is what a web app looks like. You have one page with links, and then you click, you're on the home page, then you click on the login page, or you click on the about page and that opens, and then you have different links and so on. And eventually, if you start building page by page, then you eventually build a full sitemap. So this is where the full application looks like. It's a graph. And that graph looks awfully a lot familiar to something that we already know. So in machine learning pipelines, it's similar. And I'm going to use Kedro terminology here, but you can apply it to anything you're familiar with. You have a node, which is a Python function in our case, and you have a bunch of input data sets. They're being processed and they produce an output data sets. So it's pretty clear. And then when you combine enough of those nodes, they become a pipeline. So they become something complex as this, right? Another visualization from Kedro Viz. So a bit more complicated. So it's not a sitemap exactly, but it's a graph, and it's a very specific type of graph, which is a DAG, which is directed acyclic graph. So there is one small difference with the previous example with web apps, is that their sitemaps are not guaranteed to be DAGs. And this is I would say, pretty big difference. But for machine learning pipelines, that's also true. Only in certain cases, and actually most people would go with directed acyclic graphs because they simplify a lot of our reasoning, and it makes things so much clearer and easy to use. So we eventually settled as a community on that. We are all using DAX. So that's if that's not a big enough similarity to convince you that we might draw some inspiration from web apps, I want to show you two source files. One of them is on the right side, you have the Kedro register pipelines method that will register the pipeline. And on the left side, you have Django's routers, or they call them URL patterns. It's usually urls.py or something like that. I'm not that familiar with Django, but know the basics. So this is what a pipeline is. So you have a node which will redirect things to the function if that input is available, model input table, and then it will produce those outputs. So model input table and parameters, X train, X test, Y train, Y test, and so on. So this is the split data node. And then you have different nodes here. So you build a pipeline. On the left side, you have URL patterns. So if you go on that URL on the website /user/something, then behind that include, there is probably another set of URL patterns, which eventually leads to each different URL has a function that you call when you click on that link. Again, to me, this is pretty similar, right? So you have a node which redirects things to a function, and then on the left side, you have a URL that redirects things to a function. So let's look at the controllers and /nodes here. On the right-hand side, you have some code from Kedro's example for spaceflight tutorial, and on the left side you have some random. In Django they call them views, but then essentially these are action controllers or controllers. In different frameworks they call them this way. So you have here, this is the function. It gets the data as an input, and it returns some data as an input. So it's just a simple function. Gets data as an input and returns the data as an output, and so on. You have the same thing. You get the point. So not too complicated. What do we have in Django world? So we have a request, which is essentially a data, which might be some form data, right? The users can enter data in the form. And that's what the request is. And then you do something with that data, essentially interacting with the database. And then after you're done, you updated some of the data and then send those changes to the view so the user can see those changes. And this happens like in all of those, action controllers or views, whatever terminology you want to use. Not too dissimilar in my opinion. So now trying to make a bigger stretch, and we'll try to find similarities between the models and the data sets in Kedro. So I agree, like in this case, the similarity is not as striking as in the other cases, but essentially there is still some similarity because here we have the data. And then we specify that we load the data from a certain file and we load it from a certain format. And some of our users actually add the schema here for their data. So the schema is like which field in their flat like table, or maybe we can call those tables. What's the type of each field and so on. So that's what they do, like in all of those. Now let's look at the models on the left side, which is in Django. Models essentially they define the schema. It's exactly like I mentioned. So you have title, and then you have content and author, permalink, and so on. And also they have some helper functions. So yeah, maybe not exactly the same as the data sets that we have, because we also specify where to load that data. But in the Django world, they have only one database. in our world, we often know that we don't interact with only one database or with only one source. We have multiple sources that we need to deal with. So we can't just have the schemas and then having only one URL where to get that. So they define the schemas here. And these are tables. Again, comment is a table, post is a table, and tag is a table. That's how they would look like in the database. So maybe not entirely convincing, but what I wanted to say with this story is that if those applications are not too dissimilar, then instead of us reinventing a new way to make sure that MLOps works for productionizing machine learning, we can draw some inspiration from the 12-factor app manifesto. And I just want to have a quick run and check if we can check against all of those 12 factors for things that happen in the industry, or at least Kedro is trying to help people to make it happen in the industry. And the first one is obviously the code base. As we already discussed, this happens a lot in the industry with some deviations. But in Kedro, it's very explicit, the idea that you have one app and then you have one code base, and then you have multiple deploys of that app. So we get a check against this one. And even as an industry, I would say in a community of data science, data engineering, machine learning engineers, and so on, this is not so poorly understood. People know about this and people apply it almost all the time, except like in some cases. So the thing about the dependencies, it was entirely alien initially, which is like it was very strange in the beginning, but I almost never see anyone not having a requirements.txt file alongside their code anymore. So this is like super common in the industry and people do it anyway. So for that part of the culture check, we also get a check here. For the configuration, I must admit that I think the community currently is not yet at the maturity that the 12 factors require. And the main reason is the difference, like people not making the difference between application config, which is how to wire your models, and your between environments config. Often they're clumped together, and that's the main way we violate that factor. But in the Kedro world, I add the white check mark here, is that the Kedro actually helps you with this to realize it and to have this. So we get a point here. So the backing services, treating backing services as attached resources. Again, if you have someone doing like things in a Jupyter notebook, that's not very likely to happen because they would hard code read CSV, like pandas.read CSV, or they will hard code the way they do things in Spark in loading the things, and that makes it very hard to swap things. However, in Kedro, this is, as I demonstrated, like a first class thing. So you have a very strict separation of the different types of config. Again, these go together, the config and the backing services. So we get a check mark here. The build, release, run phase, again, not that well understood yet in the community, even though like lots of people were starting to pick that up, at least in my experience. And in Kedro, this is super clearly defined. So we get a point here. Then the processes, execute the application as one or more stateless processes. I think as an industry and as a community, we've been quite good at this because, again, we work with long-running processes that might break at some point. We know that you can't, you usually don't run many processes in order to do things. You only do that for concurrency, which we'll talk about later. So people are kind of aware and about the statelessness. I think still some way to go. Like you keep seeing frameworks that try to keep state locally without knowing that there will be enough space for that and so on. But that happens. but nevertheless, we're quite good. So one thing about the port binding is like, it makes me wonder how relevant that is for us. And especially in the way they phrase it, because you don't care about port bindings in the machine learning world. We don't have any, endpoints that we need to trigger because that's being triggered by the orchestrators. And it's not relevant for all applications. But if we read it as a self-containment, then I think it becomes a bit more relevant to us, because if you have your application self-contained, that doesn't require an orchestrator, and it can be run on its own, then that might become relevant. However, even though we have some ways for running Kedro applications, I think even we do recommend people to use orchestrators, which, if you remember in my discussion earlier, in that point here is, they came from this factor came from the fact that people were using application containers to run their applications in. And in a way, those orchestrators are application containers. And honestly, I don't think I have seen enough to make a clear cut if those orchestrators are a good thing or a bad thing. And I would even lean on them being a good thing, because they have a very nice separation. So that factor might not be very relevant for our community. So the next one is concurrency. Again, scaling out in training pipelines or doing things is done a little bit differently for different reasons. And you know that you have services out there like Spark that can do that for you. You have Dask. We don't have to run our process multiple times to finish the job quicker. Also, sometimes people use, when they're training things, they need to branch out. So I'm not so sure that the things they prescribe in the 12-factor apps is relevant for our community. But if you look at disposability, again, this is something we're super aware with. This is from the very beginning, we know that when you run something for 4 hours, there is very high chance of it breaking and you're not enjoying the day afterward, because you might have lost something, you might destroy it. So I think at the community, we are like maybe even top notch here, because we're super aware of this problem, and we always develop applications. Even the people who just work with notebooks, I've seen them thinking about this because they know that this happens. Then you have this dev and production parity. It's been like sometimes being considered, sometimes not so much. But in reality is that we are way more aware, and you can judge by the way that people start developing platforms. There is always, like these AWS platforms and things, they try to make sure that the development and the staging and the production environment are very similar. So you just need to work in that one environment. You don't need to work locally. So you have Jupyter Hub, for example, or some kind of branding on top of it that makes it possible for you. Running locally, by the nature of the work, often the workloads are quite big for a laptop, so people don't, maybe sometimes they do, maybe sometimes they don't run locally. But I think we are on the maturity curve, we're there. And then, treating logs as event streams. I think here we still have some way to go as a community, because people tend to use the logs for anything and everything, and then even make decisions based on that, as I mentioned earlier. Nevertheless, I think we are getting there as well. And in Kedro, that's extremely easy. That's actually the approach we've taken. And for admin processes, I think we're getting there as well, because we have these one-off scripts. We're familiar with that. And in fact, if anything, sometimes it's hard for us to move off of those one-off scripts. But having those checked in with the same thing as the repo, is something we do. So overall, I think that those 12 factors are relevant, and that means that we should somehow draw inspiration, and this will result in way more machine learning projects getting to production, which is probably the current problem we experience as an industry and as community. There is lots of nice ideas, lots of investment in AI and machine learning, but for some reason, not everything gets to production. And that doesn't mean that it's only technical reasons, but if we can remove the technical barriers for getting things to production, then I'm pretty sure that can move the needle quite a bit. So yeah, thank you for your time, and I hope to get some nice discussion now and hear some people challenging those ideas or like even sharing. And you can see some links here to learn more about Kedro and the 12 factors and also some new features of Kedro in the YouTube video down there.
Awesome. So cool, man. And for anybody that wants to follow along or check out these slides, I just threw it in the chat there. And so you can have it for later if you want to. And anybody got any questions? Well, all right. Could you do a more in-depth comparison between MLFlow versus Kedro?
Sure, yeah. So MLFlow, I think the primary concern of MLFlow is to do some kind of like tracking and monitoring of your applications and your models. They have a bunch of different offerings. One of them is, being a model artifactory. So once you train a model, you promote it to their artifactory. And then after that, after promoting it there, then when you're trying to deploy things, you deploy the model. One of the best uses of MLFlow, at least what I have seen, is about their experiment tracking. So where you have a different experiment, you run many times, and like when you're developing a model, you want to see how your model behaves and what was the accuracy of that model, and then pick the right one. So they are fairly good at like being complementary at what they do, because in Kedro, it is for you designing the pipeline, where in MLFlow, they have some rudimentary way for designing the pipeline, running those pipelines. But their main offering, the main thing that they're really, really strong at, is this experiment tracking, where you have dashboards to see how different experiments run and how they evolve, and which of your trials and which version of your code produces the best model. So yeah, that would be
like
my take.
They're a little bit complementary in a way, or
yes. Yeah, we have a lot of our users, they use MLFlow for experiments tracking to make sure that they log everything in the way they develop their models.
So next question, web app development today is really heterogeneous and messy. There are so many tools you need to set up a new project. What lessons can we learn as we think about the analogy to MLOps?
Okay, so one thing that happened to web app development is the introduction of single page apps. So I think that made it a little bit messy. And the reason for that is because everything moved, client side. And they started the same journey as we started. So they started from scratch without looking back, without seeing if someone invented it. And they were doomed to repeat some of the things that happened before. Like, for example, in Angular, they have the MVC pattern. In some of the other frameworks, they have the MVC pattern. If you look at, for example, React, which is probably the best thing out there at the moment, or at least the most popular, I can't judge, the qualities of different JavaScript frameworks, but they all follow very similar architecture with MVC, where in React is just the view there. And I think one thing that we can take from this development is some way of having a culture that also learns from past mistakes in different fields. We need to instill that in our culture. It's like seeing what other fields have done, and not dismissing that was done, everything that's done before. But also one other thing is trying to do more interoperable things. And I think that's something we're failing because of the way different big companies try to take the space and build those platforms. And then you will be in this walled garden, because this is probably the main way our community might fail. You will be stuck forever with AWS's offering, because it will not be as easy, lift and shift and go to GC, to Google Cloud Services. You will be stuck forever with Azure if you start building things in Azure. And this is something we should not allow to happen, because it's not in the best interest of the community, and it's more commercial interest for big companies.
Great point. So, man, awesome stuff. I really appreciate you doing this. And for everybody that is still hanging around, if you're not in the MLOps community Slack yet, join it. What are you doing? Get in there. There's all kinds of these conversations and more that are happening in there every day, almost every hour, pretty much, in the MLOps questions answered channel. And Yvonne, Kedro, awesome stuff. I appreciate you walking through it with us. If anybody wants to check out Kedro, they've got the links. You can find it. And if anyone wants to reach out to you, we've also got the links on that slide deck. This was super cool, man. I really appreciate it.
Yeah, it was awesome having being here and being part of the community.
Yes. All right. Thank you, everybody, for joining us. And if you're watching in the future, give us a like and a subscribe and all that fun stuff that they do on YouTube. So we'll see you later.
See you. Bye-bye.